Hi guys, this video is in continuation with the video on explanation of the question profitable paths of Codechef Cookoff 2020. So I suggest you to just go and watch that video for the explanation, and if you are looking for the code, you are welcome to watch this video. So let's start. So I'll be coding in C++ language. So let's change iostream to bit/standard C++.h. This library helps you include all the headers, so you need not worry about the headers. So now what we are given some test cases t. Now for all those test cases we will be having some sequence of integers n, right? So this can be these integers can be very large, up to 10 to the power 9, so we will take long int, right? Let's name this array as capital A, and there will be n elements for it. Let's take input of all those elements, right? All right, now to represent our tree we can make use of adjacency list, which we can represent using a vector of vectors, right? And also, to exclude this confusion of long int, when to use and when not to use, we can simply replace the meaning of int with long int. So let's define ll as long, and now let's define int as being ll. That means anywhere in the code wherever there is written as int, it will be replaced with a long int, right? All right, so now we are taking a vector to represent the adjacency list representation, and let's take its size to be 3,05,000, because we are given the size at max can be 3 lakh, right? There can be 3 lakh vertices in the tree in any test case. All right, now first of all, every time you should clear your vector, because for every test case we need to clear our vector, otherwise there will be some garbage value residing in that vector. All right, now we are given the input of n-1 edges. So int I is 0, I less than n-1, and I plus plus. We will be given two values like u and v. We will take input of those, and we will store them in the adjacency list. Like adj of u will get a pushback v, adj of v, we will, in the adj of v we will push back u. All right, and also let's make u 1 less and v 1 less also. Why? Because we will be storing things in zero based on zero based indexing, so, and according to the question they are 1 based, so we can simply take u minus minus and v minus minus. All right, now as we discussed that for the case if n equals to be 1, that is there is only one vertex in the in the tree, then answers will go, simply gonna be 0. Why? Because there will be no leaf to leaf path, there is only one leaf there, right? Now as we discussed also the second case, that is where n equals to 2, the output will be nothing but the sum of the values. Let's take a sum variable over here, initialize it with 0, and add every sequence element into it. All right, also take modulus with mod. Why? Because according to the question we need to take a mod with 10 to the power 9 plus 7. So let's define a mod with 3 4 5 6 7 8, right? And for 9 plus 7 we need to take a mod with. So for the case n equals to 2 we will return the sum, because there will be only one pair of leaf nodes, so it will include all the elements or all the vertices in the tree, right? Now there is the else case, where first of all, as we discussed, we will be having a total leaf count which will make 0 every time when we enter in here, because this value will be changed because we are taking it in the global scope, right? All right, now we will be declaring all the arrays that we'll be going to use. So as discussed in the problem, we will be having a counts array of size 3,05,000. we will be having a degree array in which we will be storing the degrees of every vertex. We will be storing a C-leaf array in which we will be storing the count of or leaf variable in which we will be storing the count of the leaf nodes in the subtree, or in the tree rooted at that subtree rooted at that particular node, right? All right, so let's also store the degree count in the degree array. All right, now in the else case, that means we are having more than 2 vertices in the tree. That means there will be more than or equal to 2 leaf nodes in the tree. So first of all, if for every node in the tree if that particular node is having a degree of 1, that means it is a leaf node. So we will make the leaf we will increment the leaf count, but else, that means the degree is not equals to 1, that means we can take that particular node or vertices as the root of the tree. So this is how we can let's take a variable root over here, which can serve the purpose of the root. So we'll take that non-leaf node as a root. All right, now we will call the DFS with this root and -1 being its parent. That means there is no parent for the root. So let's write the DFS function here. The return type will be void, and we are having a current node, that means the root, and we are having its parent. Now if the degree of current node, that means the current node is 1, that means it is a leaf node, and for the leaf node we will say that the the leaf counts in this subtree rooted at this current node will be nothing but 1. But if degree of current node is greater than 1, if not 1, then we will make leaf count of the subtree rooted at the current node as 0. And now we will start with our DFS call for every node, for every vertex is connected to this particular vertex. That means ADJ of current size. Now if that ADG current I is not equals to parent, right, that means that particular node is a child of that current node. So we will do a recursive DFS call on ADJ currents I and current being its parent, right? Now we will store the answer recursively in this way. The answer of leaf current will be equals to the sum of leaf current plus the answer that we will get from our recursive call to currents I, right? This is what we will do. All right, now as we discussed in the solution, we will find out the number of times each particular node is occurring in any path in the tree. So now for every node, so sorry, for this particular current node, if ADJ's current and I is not its parent, what we will do, we will say that we'll take a variable value which will store the count of number of times it appeared in any path. Value will be plus equals to the leaf count of current node subtract with the leaf count of current node and I times the leaf count of ADJ the leaf count of ADJ current I, as discussed in the solution. All right, now because using this formula we will be counting every pair 2 times, so we will make value divide equals to 2. All right, now value will be, we'll also get another part as discussed in the solution, which will be total leaf subtracted from which we subtract the leaf current count multiplied with leaf current. All right, now we will save this value in the counts array at the current position, right, for the current vertex, right? So the counts at current position represents the number of leaf nodes in the subtree rooted at current vertex, right? All right, so this is how we have done the depth first traversal of the tree. Now all we need to do, as we discussed in the solution, first of all we need to sort both the arrays, right, array A as well as the counts array. All right, and then all we need to do, we will need to take the product of every element of array capital A and counts array, and we will store that in a variable answer. All right, so answer will be equal to answer plus counts I multiplied by AI, right? Also I multiplied with AI. So this simply represents the answer. Let's print the answer. Let's just take a short tour to the code and check out if there is something wrong in the code, that or something we just left out. If everything is fine, we are good to go to submit the code. So let's run on the custom input. Let's check out whether it's working fine or not. There's a comparison error. It says main must return int. All right, because we have said that int anywhere in the code will be replaced with long int. So we can simply, remove it in C++. We can do so. So this is giving 24, but this is giving 0. No, the answer should be 15, I guess. Yes, 24, 15. There must be some mistake in the code. Let's see what could be the potential error. All right, the degree array should also be made, every time equal to 0, because we need to renew for every test case, right? Our array. Let's check out whether it is working fine this time or not. Yeah, it's working fine. Let's submit our code and check out whether it's completely correct or not. Yep, so it's working completely fine. Thank you for watching. Please do like, share and subscribe my channel. Stay tuned for my upcoming videos. Bye bye.